going to take a look at this circuit to understand a couple things. About voltage across the wire, 0 volts is good. Let's clarify what we have here. We have measurement 13 is simply the voltage across the wire between the plus and here. In other words, remember, a fuse is going to act like a piece of wire, and we'll see what we get there. Then we've got our voltage reference here. We have a voltage reference across this wire in wire 58, and it shows 0 volts, and wire 52. Now when I activate the circuit, we see it's working, but that's made no difference to any of these voltages. We see we've got a current reading showing this bulb is drawing an amp, and all is good. So it's key, whenever you're measuring across a wire, you're always going to get 0 volts, and that means the wire is good. It's not a great test, because you could get that if the fuse blew. Let's see about blowing the fuse now. I'm going to go into a slow motion mode, and I'm going to short the load. That means 0 resistance. That means instead of going through here, we're going to go through here, and watch the current meter over here when I short the load. Here we go. We see it goes up to 914, then the fuse blew. That said, that's that arc. That's that big spark you get whenever you short. Now we're getting 0 volts across this wire, 0 volts across this wire. This is a little deceiving. We're no longer connected here. We're here at this positive supply, and then we find our way through the short back here. So voltage on a wire is reference to an open. What's the open? The fuse. The fuse has opened. So that's the understanding of watching how it acts. Again, to restart, I have to start the circuit. Simulation over. Here we see, again, 0 volts on all the wires. We're certainly getting the load going. And when we cause a short, bam, large current, burns open, and only the open is where we will see a voltage appear. So that's a hint if you're troubleshooting a circuit. Don't blame the wire. Well, it could be the wire, but in this case it's the fuse, or somebody cut this wire. That would explain that reading. In this circuit, we're going to look at measuring voltage from a reference point. The reference point being used, this happens to be one side of the power supply. And we can see on this one, we're measuring across these 2 points, we're getting 24 volts. Then across these 2 points, notice we're getting 0. And whether I operate the circuit or not, we get the same. And we notice that voltage continues through the switch, and we get current flow. So it's important to know that voltage on the left side of the switch should pass through and get to the load. So that shows that it's operating. So that's the idea, that from a single reference point, you get the voltage here. Now for ease of hookup, I've been using just these voltage test points, but nothing would be different if I was to take the leads and hook it on and go to the same points. There we get 24 volts. Here we get 24 volts when we close it. And this is the measurement that is key for people to get wrong. You know, this measurement's always just going to be 0. This is 0.003. It's a very accurate simulator. There is resistance in the wire. But we're always not going to see the supply because it's been consumed, the 24 volts or whatever the supply is, across the load. So those are keys to this circuit. Now, when we operate it, 24 volts is good. And now here I'm going to open the bulb. Now the bulb is bad. Notice we still have 24 volts here and 0 here. So it's looking like a good circuit. All this means is when we close the switch, the voltage is getting to X1 or to the load that we wanted it to have. But if the bulb or the relay coil or the motor coil is bad, well, then we get the 24 volts or the supply, but we don't get the activity that it should have. So that's one key thing in understanding a fault. Notice also we're getting zero current draw. Now if we remove that fault, the bulb's back, it's drawing its current, and all is good. Again, if we should short the load and operate it, I'm going to go into slow motion so you can see what's going to happen. We're going to see, we're going to get voltage. This current's going to go way up, and then the fuse will blow. Here we go. It started to develop a voltage. This current went up and blew. I'll come out of simulation again and go back in. That restores the fuse. So here we've got our 24 volts, our 1 amp, and in slow motion we'll short the load and see the process of drawing too much current.